Hello everyone. So we were doing questions on operational amplifier, which is a part of analog electronics. So let's just move on with our questions. So what does our next question says? Next question says that, so it's saying that for the operational amplifier circuit, the output saturation voltages are plus minus 15 volt. The upper and the lower threshold voltage for the circuit are respectively. So in this question, they are directly mentioning that they want to ask the upper and the lower threshold voltage. That means this particular circuit is a Smith trigger, right? It is a Smith trigger, and the output is giving feedback to the positive terminal. Whenever the feedback is connected to the positive terminal, that means from the output the feedback is coming to the positive terminal. That is a Smith trigger, and in that case the maximum voltages at output can be plus minus V saturation. But whenever they are asking us the upper and lower threshold, so how we calculate upper and lower threshold? We find out the relation between input and output. So this is the input and this is the output. So maximum output will be plus 15 and minimum output will be minus 15. So for upper and lower threshold voltages, what we do is we find out the value of input. So let's just take, this is Vn only. So let's just apply KCL at this node. So if we apply KCL, what do we have? So taking both the current direction in, so V out minus V in by 10 plus 3 minus V in by 5, that will be equal to 0. Right, now we can simplify it in order to find out V in. Plus 3 by 5, that will be equal to V in by 10 plus V in by 5. Right, so what will the LCM? V out plus 6 is equals to V in plus 2V in divided by 10. This will cancel out. So what will be the value of V in? So that will be V out plus 6 divided by 3. So this is the relation. This is the first step to calculate what threshold voltages. Now we have to just put the maximum and the minimum values of the V out, right? So for upper threshold voltage will be equal to 15 plus 6 divided by 3. 15 plus 6 divided by 3. So what will be this upper threshold value will be 15 plus 6 will be 21. 21 divided by 3 will be plus 7. That will be your upper threshold voltage. What about the lower threshold voltage? Lower threshold will be minus 15 plus 6 divided by 3. That will be minus 9 by 3. So minus 3. So this is your upper threshold and this is your lower threshold. So option B will be your correct option. Easy question, right? Okay, moving on to the next question. Let's just read what next question says. So next question says that for the circuit shown in the figure, R1, R2, R3 is equals to 1. So values of all the resistances are given, which is equals to 1. L is equals to, which is inductor, is equals to 1 microhenry, and capacitor is equals to 1 microfarad. Both are in micro. Output, V in is given in cosine, so that is a sinusoidal. So this is cos 10 raised to power 60, right? Then the overall voltage gain V out by V in for the circuit will be what? So let's just do one thing with this circuit. Let's just change this capacitance and inductors into their equivalent reactance. You can take a Laplace, you can take Fourier, whatever you want. So Laplace will be easier because there is nothing like J in that, and we can just cancel out S terms if it has to be. So let's just change this into their equivalent reactance, so that will be SL. And what about this capacitance? So capacitance will be 1 by SC. I have taken Laplace. You can take Fourier, whatever suits you, right? Now what we have to do is, there are two operational amplifier in this case. We have to find out the gain stage by stage, because we have to find out the overall gain. This is overall gain, output by overall input. So this is your stage number 1. Let's just mark this output be V01. So this for first stage we'll calculate, then for second stage, and then we'll find out the final gain, right? So for the first stage, let's just find out. So we'll just apply simple. This will be V in KCL at this node N. Right, so if we apply KCL at N, what will be this? So 0 minus V in divided by SL. So current going like this, both entering. So 0 minus V in plus V01 minus V in divided by R1. That will be equal to 0. We know all the values, so this is also 1. This is 1, right? What will this be? S into 10 raised to power minus 6, and this is also, this will be 1 by S into 10 raised to power minus 6. This is also 1. So we can replace everything. So what we will get is V in divided by S into 10 raised to power minus 6 plus V01 minus V in divided by 1 is equals to 0. What we have to find out is, we have to find out V01 by V in. So let's just break it into 2 more steps in order to find it out, right? So V in by S into 10 raised to power minus 6 plus V01, or I can just do one thing, minus plus V in is equals to V01, right? Taking V in common, so V01 divided by V in is equals to S into 10 raised to power minus 6 minus 1 divided by S into 10 raised to power minus 6. So this is the gain of the first stage we calculated, right? This is the gain of the first stage. Now what we have to do is, we have to calculate the gain of the second stage. Second stage, you can see directly, it is what? This is negative, and input is connected to the negative terminal only. So this is non-inverting amplifier, right? So for inverting amplifier, we know what will be the gain is. Gain is equals to minus. So this is, so let's just take this. So gain for non-inverting stage 2, we directly know this is non-inverting amplifier. So we know that V out by V01, what will be this? Minus of this R3 divided by this total resistance here. So we can easily calculate, that will be R2 plus 1 by SC. So that will be the total gain, right? We just need to solve this down little bit. So that will be minus 1 plus 1 by S into 10 raised to power minus 6. So what will be this? This will go up, S into 10 raised to power minus 6, S into 10 raised to power minus 6 plus 1, right? So that will be the gain. So now we have both the gains. There's something wrong. Okay, I forgot this minus, right? So this will be positive only, right? So this is plus. I forgot this minus here. So this was 0 minus V in. I just took V in, right? So now we have gains like this. Now in order to find out the total gain, so what we have to do is V out divided by V01 into V01 divided by V in. Simple. This cancel out, so we will get the total gain. So that will be V. So whenever you get the case of multiple stages, what you have to do is solve stage by stage, be it 3 stage, 4 stage, no matter how many stages they give you. You must know some direct solutions for a few of the stages. Like in the second stage, we can see even in the first stage, we can directly say that it is a case of non-inverting amplifier. So that was a non-inverting amplifier. I just solved it for you. So that was non-inverting amplifier, and this is the case of sorry, this is the case of inverting amplifier, and the stage 1 was the case of non-inverting amplifier. So we know directly the result of non-inverting amplifier. From that also you can calculate it. So that should be V0 1 divided by Vin is equals to 1 plus this resistance R1 divided by this SL. So that will be the direct result. From this we will get this, and from the stage 2, which is inverting amplifier, we get this, which is equals to minus of R3 divided by R2 plus 1 by SC. This is the case of second stage. Now for the complete gain, for the gain of all the stages, what you have to do is multiply the gains of each of the stages. The intermediate output will cancel out automatically, like this. I have taken the gain of the second stage, this is the gain of the first stage, I have just multiplied them. Now after multiplying them, we will get V out by V in only. We have the gains of both the stage 10 raised to power minus 6 plus 1 divided by S into 10 raised to power minus 6 multiplied by minus S into 10 raised to power minus 6 divided by S into 10 raised to power minus 6 plus 1. This and this all will cancel out. The gain final will be minus 1. So final gain will be minus 1. We can easily say that directly also, because this is what, this is a case of non-inverting amplifier, this is the case of inverting amplifier. All the values of resistance and capacitance is equals to 1 only, right? So in that case, I have a sinusoidal waveform, right? It will invert it, but in this case I will get an output like this, minus cos 10 raised to power 60, right? Something like that. And this is a I'm saying it reverse again and again. So this is first stage is the case of non-inverting amplifier, so it will not invert the amplifier, the output will be something like this, right? And here it will just invert the gain, right? So this will be minus cos 10 raised to power 60, right? What we will get is a negative input. So that's how we can verify the gain also. So what is this gain? Minus of 1, right? Okay, moving on to the next question. Okay, next question says that an op-amp has a finite loop gain of 100. Its input offset value IOS is equals to 5 millivolts is modeled as shown in the circuit below. The amplifier is ideal in all the respect. V input is equals to 25 millivolt. Now in this case, what they are saying is very important thing is the op-amp is not having an infinite gain, right? The op-amp is having finite gain. So in such questions, when op-amp is not given as ideal op-amp, because ideal op-amp has infinite gain, right? So how do we solve such questions? In these questions, you cannot assume that the voltage here is equals to voltage here. How? Because there is a concept of common ground in op-amp when it is given as ideal, right? So how we get that concept is, so I know input is equals to gain. If I am talking about the open loop gain, if I am just taking this op-amp, so this is the output and this is the positive terminal and this is the negative terminal, right? This is how an op-amp look like. And if I want to find out the open loop gain of an op-amp, that will be V0 divided by the differential voltage Vd is equals to open loop gain, which is equals to this AOL, right? In this case, what is this difference voltage V0 divided by V positive minus V negative is equals to open loop gain. This is how we can we always write it. Now we know that open loop gain of an ideal op-amp is equals to infinite. So this is equals to infinite. In this case, I can say directly that if this is equals to infinite, V positive minus V negative will be equal to 0. So from this concept, we always consider both the terminals of an op-amp to be at same voltage, right? But in this case, our concept won't work like that. Why? Because they have given us a finite gain in this case. So suppose if we have some finite gain, so what will be this? V naught divided by V positive, V negative, that will be some finite gain. Let's just say that will be a value. So what is this? V positive minus V negative will be equal to what? It will be equal to V naught by A, something like that, right? So from this I can say that V positive will be equal to V naught by A plus V negative. So they will be having some voltage difference like that, which difference will be given by V naught by A, right? For, for this concept, our formulas for non-inverting or inverting amplifier do change, right? They will change. Right? As you can see that input is given to the positive terminal and feedback is to the negative terminal. So what is this topology basically? So this is a non-inverting amplifier because input is given to the positive terminal. So non-inverting amplifier gain is given like, so output divided by the input is given like 1 plus the feedback resistance and the input resistance. But in this case it will not work like that because it is not the case of ideal op amp, right? It is not the case of ideal op amp. So how we have to take it? So this is what? This is the input terminal. This is the input terminal. Let's just take both the inputs will be equals to 5 plus and 25 millivolts is given to us. So that total input will be 30 millivolt. I cannot say that this will be same as 30 millivolts. So what will be the value of voltage at node negative? So what will be this value? So V positive minus V naught by A will be equal to V negative. So from this I can find out the values for both the terminals, V negative and V positive. I know all the values in this case, right? So this will be, let's just say, so this is V positive minus V naught by A, right? This will be the value of positive terminal. Now let's just solve. I am removing the concept and I will apply KCL here in order to find out the gain. Right. So in this case, if I apply now, if I apply this gain, so V positive, we know that it is equals to 30. 30 minus V naught by A will be the value of value of V positive. Now we will apply KCL at V negative. Right, this is V negative terminal. Now both the currents are entering, there is no current going inside the op amp. So in this case, what will be the value? So V naught minus V negative divided by 15 plus 0 minus V negative divided by 1 is equals to 0. Just replacing everything, right? So V naught by 15 is equals to V negative by 15 plus V negative. All are in kilo, right? So that will be 16 V negative divided by 15, right? So V naught by V negative is equals to 16. From there we get, right? Now this V negative is not V negative exactly. So V naught is equals to, I am replacing V negative as well. So V naught will be equal to V negative into 16, right? So what is this V negative? So that will be equal to V positive minus V naught by A into 16. Keeping V naught on the other side only. V naught is equals to 16V positive minus 16V naught divided by A. So V naught plus 16V naught divided by A is equals to 16V positive. Now solving it, so that will be AV naught plus 16V naught divided by A is equals to 16V positive. We know the value of the gain, right? We know that A value is given as 100. So if we put down the value of A, what we will get is, after this I'm solving it here, so that will be 100 V naught plus 16 V naught divided by 100 is equals to 16. V positive value we also know, so that is equals to 30 milli. So that will be equal to 16 into K, so that will be 10 raised to power 3, and 30 milli will be equal to 30 into 10 raised to power minus 3. So now from there, so that will be 116 V naught divided by 100 is equals to, if we solve that all up, what will be the final value of V naught? So V naught is coming out to be 413.7. 413.79 millivolts. So this is the final value of the V naught which we are getting. Right? I can even solve this on calculator. Let me just confirm it. This is the final answer which I know. Yeah, so it is 413.79 exactly. So this is the final value of V naught. Right. I can give you a direct formula for such cases. Whenever you have cases like this is what I solved by putting all the values, right? But not to go with all this confusion, if we know the final result or direct result for the cases like this was a non-inverting amplifier. So if we know the direct result, suppose so this is the case of non-inverting amplifier. We know the gain for the ideal op-amp, so that will be V naught by V in, that comes out to be 1 plus RF by RN. So if the case like this is given, like finite loop gain case is given, this is for infinite loop gain, and for finite loop gain what you have to do is to divide this factor with 1 plus A naught, 1 plus, and the gain again, like this. So this is what you have to do. 1 by A naught, it should be 1 by A naught. Right, so this is the direct, this is also given directly in Sedra-Smith, right, your main book for analog electronics. And this complete will be for finite loop gain. If we directly put this value here, so that will be 1 plus 1 by RF is 15. 15 by 1 divided by 1 plus 1 by 100 divided by 1 plus 15 by 1 into 30 millivolt. This will also come out something like 413.79 millivolt, similar to the previous case. If you directly want to put it into a formula, so that will be your final result. Okay, moving on to the next question. Okay, so next question says that in the circuit shown, assume that the op-amp is ideal. If the gain V0 by Vin is equals to minus 12, we have to find out the value of R in kilo ohms. So in this case, what they have given is very easy question. They have given us the gain, direct gain. What will be the final value of the gain? You have to find out the value of this Rx. So let's just assume that voltage here is equals to Vx. What you have to do is apply KCL. This is node A and that is node Vx. So first let's just apply KCL at node A. So what will be this? So both the currents incoming. So V in minus A, which is equals to 0, right? 0 divided by 10 plus Vx minus 0 divided by both are 10k, so that will be equal to 0. From this we can directly say that V in will come out to be equal to minus of Vx. This is the first case. Now in such cases, when you have like circuit like this, like not a simple circuit, not a single resistance circuit at a feedback, so you have to go with multiple KCLs, right? So we have to again apply KCL at this, KCL at Vx as well. So now 3 currents are incoming. So let's just say 0 minus Vx divided by 10, right? Plus V0 minus Vx divided by 10 plus 0 minus Vx divided by R is equals to 0. Now what they have given us? They have given us gain. So gain is V0 by Vin. Now I have, from the first KCL, I have relation between this Vin and Vx, right? In the second equation, we can see V0 and Vx. Vx, we know that it is related with Vin somehow, which is what? Vx, Vin is equals to minus of Vx. So I can simply substitute Vin instead of minus Vx into this equation, so that I will get a relation between V0 and Vin. And if I find out the gain from this equation, what I'll get, the gain value is minus 12, only one unknown will be remaining, that will be equal to resistance, and we will be able to find out the value of the resistance, right? So I'll just replace minus of Vx plus Vin. So that will be Vin by 10 plus V0 plus Vin by 10 plus Vin by R is equals to 0, right? So V0 by 10 on one side and all the Vin term on the other side. So that will be Vin by 10, Vin by 10, Vin by R. Take out the Vin as common and put it on that side. So let me just solve it here. V0 by Vin is equals to 10 by 10. All are in negative. This 10 will go here and Vin common will go at that position. Plus 10 by 10 plus 10 by R. So we know that it is equals to minus 12. So that will be equal to minus 1 minus 1 minus 10 by R. So R will come out to be 1 ohm only. R will come out to be 1 ohm. Minus 10 is equals to minus 10 by R. So R will come out to be 1 ohm. 1 kilo ohm rather, because all were in kilo ohm. 1 kilo ohms. So that will be the value of the resistance R. Easy. All the operational amplifiers questions are very easy because you have to know just one concept or two concepts in this case, and most of the time they'll ask you about the ideal op-amp case only. The previous case was a non-ideal op-amp case, and you will when you'll go through this op-amp, you will always remember that what is the non-inverting configuration and what is the inverting configuration, and if you know that, you can crack any op-amp question like this, right? So that will not be a big deal. You have to just have a strong hold on your concepts on KVL and not even KVL, only KCLs. How we apply KCL? Just take one node and take all the currents incoming, and you just take the direction for the incoming current. So this is the voltage, this is the voltage, this is resistance in between. Suppose there are multiple components of resistance, one resistant, two resistant, one inductor is given, one conductor, one capacitor is given. So what you have to do is take the combination of that and just assume it at Z, and in that case also, so the current will be V in minus 0 divided by that Z. So that is how easy KCLs are, right? Okay, move on to the next question. Next question says that, assuming that op-amp circuit is shown below is ideal, the output voltage V0 will be equal to what? Now, in this case, op-amp is given as ideal. This is a very trick question. Op-amp is ideal, but they have directly given potentials to the positive and negative terminal. So this is the positive terminal and they have directed it with 1 volt. This is the negative terminal, they have directed it with 0 volts. So what happened in the such cases? So now V positive is not equal to V negative here, right? This is not the case. V positive is not equal to V negative because this is ground at 0. Sorry, this is V positive at 1 volts and V negative is at 0 volts. This is grounded. Directly, directly we can see that into the circuit. So this is positive terminal, this is negative terminal, and positive terminal is directly connected to the 1 volts and negative terminal is directly connected to the 0 volt, that is grounded already. So now in this case, V negative is not equal to V positive, right? We know that output is equals to what? Just calculated open loop gain V positive minus V negative. We know that this is how we calculate the output. Now gain is what? Gain is infinite. This is given as V positive terminal is 1 minus 0. This is how we calculate, right? If we know both the values of input and output, we can directly put them, right? In the previous cases, we usually don't know, right? So in this case, what will be it? So infinite into 1. So what is this? Output can never be infinite. Output can either be, if it is coming out to be positive infinity, then it can be plus 12, which is the saturation voltage given to us, and if it is negative infinity, it can go to minus 12 volts, right? So whenever you get outputs at infinity, so final output will be always positive or negative saturation value. So infinity, so what will be the final output? So plus 12 volts will be the output for this particular type of question. Very easy question, yet tricky question.